Well, enough about segments. Let's talk about angles. Now, don't forget, pause when needed. Listen carefully. Let's get going. Let's start with the basics. First off, an angle is formed by two rays, right here and right here. They have a common endpoint, B. That common endpoint is called the vertex. All right, so we got two rays sharing a common vertex. The rays are what we refer to as the sides of the angle. And we name the angle using three letters. The middle letter must be the vertex. And we said that the vertex was B. So when we use the name of the angle up there, we're going to say angle A, B, C. Now you can use a single letter if you'd like. So if there is no other angle there, then you can just call this angle B, because I won't get it confused with other angles. Now take, for instance, what I've created here. Now I have another ray starting at point B. So now I have this angle right here. I have an angle right here, and then you have the big one. So there's really three angles here. So I can't call angle B any of them because it would be ambiguous. I wouldn't know who you're talking about. So I would have to say, well, when I'm referring to angle 1 right here, I would call that angle DBA. And if we call this number 2, we would call that angle ABC, and so on. If we want to refer to the big angle, we would call it angle DBC. Lastly, when referring to the measure of an angle, we're going to use the little m in front, and we'll say the measure of angle ABC, its name, is equal to 60 degrees. And that was the original angle that we were talking about. All right, let's move on. Types of angles. Yes, angles have types, right? You know, sometimes you suggest to an obtuse angle, you know, you should consider dating an acute angle. And that angle will say, no, it's not really my type. Okay, bad jokes. The acute angle, right? We have an acute angle, and we have the obtuse angle, we have the right angle, and then we have the straight angle. Angles are defined by their measurements. Acute angles are always less than 90 degrees and greater than 0 degrees. That's a degree mark. Obtuse angles are always less than 180 degrees and greater than 90 degrees. Right angles are exactly 90 degrees, and straight angles are exactly 180 degrees. These two will prove to be very helpful to us on down the road. So let's see how we're doing. First off, we have an example angle over here, example number 1, and we want to name the vertex of that angle. So again, remember, the vertex is the starting spot of those two rays. That is a point, always a point, capital K. When we name the sides of the angle, remember that sides are rays. And we always name rays with the starting point as the first letter, and then the direction it's going with a little mini ray over the top. So we start at K and go towards J. We start at K and go towards L. So that's going to be ray KL and ray KJ. And then don't forget a little ray over the top. Those are the names of the sides. Give three ways to name this angle. Well, we could call it angle JKL. Remember, the vertex is the middle letter. Or we could call it angle LKJ. Or, since it's only one angle, we could just call it angle K with just the vertex. Classify the angle. This is definitely greater than 90 degrees, so I would say that this is obtuse. Okay, press pause, and then you try it. Using this angle, I want you to name the vertex, the sides, give three ways to name the angle, and then classify the angle. Just a little heads up, this box right here means 90 degrees. That's just a little hint for the classification part. See you in a minute. Now, just like in segments, segments can be congruent. Angles also can be congruent, which means of like measure, right? So when you look at angles A and B right here, they look like they're the same measure. So we'll say if the measure of angle A equals the measure of angle B, then angle A is congruent to angle B. So similar to a midpoint where you take this segment AB and you have midpoint M right here. That divides AB into two congruent segments. So you got segment AM and segment AB. Well, similar to that, you can have an angle bisector. And an angle bisector is going to be yet another ray. So we have ray BA and ray BC are the sides of angle ABC. Then you have ray BD bisecting that angle. And what is an angle bisector? Well, it's just a very simple ray that divides the angle into two congruent angles. And that's the word congruent. In the diagram to the right, ray BD, as I stated, ray BD is an angle bisector. Therefore, angle ABD right here is congruent to angle DBC. Now, the only thing I'm going to do is just overturn their notation right here. Usually when we mark angles congruent, we get a little arc here and a little arc here. Sometimes you'll see it in a book that they'll put like a little single tick mark through it like that to denote that this angle here is the same as this angle here. Moving right along, we're going to move over to the notion of perpendicular lines. So as we look over here, we see this right angle. That means that two lines that intersect, right? So these lines are intersecting at a right angle. That's what that little box means. And again, that box indicates 90 degrees. That's what a right angle is by definition. So the symbol for perpendicular is an upside down T. And when I see that upside down T, I'm going to say the words is perpendicular to. So we'll say in the diagram to the right, line L is perpendicular to line M. And that's how we write that. Line L is perpendicular to line M. And lastly, we're going to deal with perpendicular bisector. What is that? A line, a segment, or a ray perpendicular, right, meeting at 90 degrees to a segment at its midpoint. So we're back to segments, and we can cut segments in half. I see that this segment's been cut in half because I have this notation that P to the end point of intersection and from the point of intersection to Q is the same length. Who did that? LM, line LM, cut segment PQ in half. So we'll say in the diagram to the right, line LM is the perpendicular bisector to segment PQ. Now, a lot of implications from this picture. We could say, well, what if this was 3 centimeters? Well, then this is 3 centimeters. And if this is 90 degrees, then I guess on the other side is 90 degrees too, because this is a straight line. So that would be a straight angle. So I guess that whole thing is 180. And if that's 90, that's 90. A lot of stuff coming up. Now let's take a look at this picture in example number 3. What are some of the things I notice? I notice that this angle and this angle are marked congruent. I see that this segment and this segment are marked congruent. I see that this angle right here, DBC, right, DBC or CBD here, is 90 degrees. Given all this information, let's answer some questions, all right? Write another name for angle CBF. So CBF is right here. Now again, I really don't even need to look at the picture to rename that. I could just call it angle and the same name in reverse order. So FBC. Okay. Name the sides of angle EBD. So again, knowing what I know, that angles are made up of two rays, we're going to say, well, it starts, right? The vertex is at B, right? There's the vertex of this thing. EBD. So EBD, this big angle right here. Well, here's a side and here's a side. Sides are rays. So ray BE and ray BD. But just for the record, if I just looked closely, I'm going to say ray BE and ray BD right from the name itself. Now, we're going to need to classify angle ABC. Let's trace it out. Angle ABC starts at A, goes to B, and then down to C. Oh, that looks like this angle here. That's a straight angle because it's a straight line. So I'm going to say that's straight. Remember, that's equal to 180 degrees. All right. Give an example of an obtuse angle from the drawing. So first, I just want to look for an angle that's opening wide open. So I'll say, well, how about EBD here, right? So I think EBD is an obtuse angle. So I'll say angle EBD. How about another example? How about starting from A to B to F? So angle ABF. F. It's another obtuse angle. Name two congruent angles. All right, so I said that we had this angle here and this angle here were marked congruent with those arcs. So we just need to name those angles. That's starting at E, going towards B, up to A. So angle EBA is congruent to angle CBF. CBF. And then the last one, we're going to need a perpendicular bisector. Wow, that's a bunch. Now, first off, remember that a perpendicular bisector is a line, segment, or a ray that meets a segment at its midpoint. Now, I see that AB is marked congruent to BC, right? There's those congruency marks. So it looks like AC, segment AC, was the thing that got cut in half. Who did the cutting in half? Looks like this piece met it at 90 degrees. So I think that ray BD is the angle bisector. Now, if any of this was too fast, stop the video, go back and rewatch this. Let this sink in. Okay, now it's your turn to try. Name the vertex, sides, write another name for an angle, right? Classify, and again, just trace. Like for instance, G, classify X, T, U. Start at X, go to T, L to U. Looks like that's a small angle. So what's the name for small angles that are less than 90 degrees? Name two perpendicular lines, okay? I see two lines here forming a 90-degree angle. Just name them using two letters, and don't forget to put the little line notation over those line names. Name an angle bisector, right? Line, segment, or ray. It looks like, to me, that this angle here form two congruent angles. Angle 2 and angle 3 are congruent angles. So who did the bisecting there? Looks like this ray right here. So name that ray with the little ray notation. All right, you're on your own now. All right, so remember we had segment addition postulate. Right, we had the segment addition postulate, SAP for short. Well, we got the angle addition postulate, AAP for short. Now remember, the segment addition postulate said that if you take this piece here, add to this piece here, you get the length of the whole thing, or that DP plus PB equals DB. Now we're going to do the same thing with angles. And we're going to say, well, hey, listen, if you got a point that's in the interior of angle ABC, right? Where is D? It's inside of this big angle. Well, then guess what? We got 1, 2 small angles, and then we got the third big angle. And all we want to do is be able to name them properly and put some addition and equal signs in there, just like we did for the segment addition postulate. So first off, let's name angle 1. We're going to say the measure of angle ABD. That's this dude right here, angle 1. Now I'm going to call this angle 2. I'm going to add that to the measure of angle DBC. And what's that going to equal? That's going to equal the big one, what I called angle 3, the measure of angle ABC, right? Small angle plus the other small angle equals to the bigger angle. Makes logical sense. So let's put this into action, right? So we have angle ABD. So let's go find angle ABD. That's this angle right here. And that's worth 48 degrees. Okay, so I'm going to say that's 48. And then you got DBC. DBC is worth 78 degrees. So DBC is right here. So that's worth 78 degrees. And I guess if you add those two together, you're going to get the value of ABC, which is the big angle. So 48 plus 78 equals the value of ABC, which is 126 degrees. That's the measure of angle ABC. Okay, let's try again. Same picture, but new evidence. DBC is 74 degrees, so that's right here. And ABC equals 119. That's the big one. So I'm going to draw an arc like that. I'm going to call that 119. And they want the measure of ABD. Now, ABD is this little one, right? So I'm going to call that X. So I think this time I'm going to subtract, right? X is going to be the 119 minus 74. That's going to be the measure of that angle. And 119 minus 74 is 45 degrees. So the measure of ABD is going to be 45 degrees. Okay? Don't forget to include M for measure of when you're saying the names of angle measurements. And of course, you've guessed it, it's an algebra-based geometry class. Of course, we're going to slip in some algebra. So we got given to us in this picture, it looks like PQS here is worth 13x plus 4, and SQR here, angle SQR, is worth 10x minus 1 degree. And then it says PQR. So where's PQR? PQR is the measure of the big angle. So I'm always going to say a big arc like that, that's 141 degrees. So what do I know? I know that the angle addition postulate says that if you take this angle here, the measure of PQS, add that to the measure of SQR here, right? That'll give you the measure of the big angle, PQR. Now what? You guessed it, substitute in the algebra. So instead of PQS, I'm going to write 13x plus 4. Plus, instead of SQR, I'm going to write 10x minus 1 is equal to the large angle, which is 141 degrees. Now what? Let's combine like terms. So we're going to get 23x plus 3 equals 141. Subtract the 3 from both sides. I'm going to get 23x is equal to 138. Divide by 23 on both sides. And we're going to get an x of 6. So we'll come over here and say x of 6. Last thing they want is the measure of PQS and SQR. PQS is 13 times 4, or times 6 plus 4. 13 times 6 plus 4 is going to give us 82 degrees. All right, so that's 82 degrees. And then they want the measure of SQR. So SQR here is 10x minus 1. So again, 10 times 6 is 60 minus 1 is 59 degrees. And that's the measure of those two angles. Now, just for the record, if you take 82 and 59, you get 11. 9 plus 2 is 11. Carry the 1. 8 plus 6 is 14. That's 141. And that's what we said. The big angle was 141. So this is good to go. All right, let's try another one. So we got the measure of angle DEF. Now this time they give me the algebra in writing, not in the picture. So let's go find this. So DEF is going to be the big portion, right? And then we have DEG, 5x plus 1. So DEG is right here. And then we're going to have GEF right here. That's this little guy. So I think that the yellow angle is equal to the red plus the purple angle. Let's write it out in notation. So again, the measure of DEG, that's this red angle, added to the measure of GEF, that's this bluish purple angle, is equal to the big angle, right? The yellow one, angle D, the measure of angle DEF. Now, after we write that out, again, let's start substituting in the information. So DEG is going to be 5x plus 1. So 5x plus 1 plus the measure of GEF, 23 degrees, is equal to the measure of DEF, the large angle, 7x plus 4. Now what? Combine like terms. So 5x plus 24 is equal to 7x plus 4. Now, we want to move our x's to one side, so I think we'll subtract 5x from both sides, and we get 2x plus 4 equals 24. If we subtract 4 from both sides, we're going to get 2x equals 20. Divide by 2, we'll get x equals 10. Now, you should be showing all your algebra. I'm just shortcutting due to space, and so I have x is equal to 10. Now, to get the measure of angle DEG and DEF, we're just going to substitute in the value of x. So we were given that the measure of angle DEG was 5x plus 1. So that's 5 times 10 plus 1 is 51 degrees. All right, I'm going to remember the degree mark because I'm measuring an angle now. And the measure of angle DEF is 7 times x plus 4, which is 7 times 10 plus 4, or 74 degrees. Now don't forget that it was given to me that GEF was equal to 23 degrees. So since this is 51, and they said that was 23, 3 plus 1 is 4, 74, which is what we said DEF was. So the angle addition postulate works. I add up the two smaller angles, I get the larger angle. So my algebra is good and my measures are good. Good. So for the last one, you go ahead and try it. And I'll walk you through it. JKM is 43 degrees. Well, that's JKM. That's the 43s right there. MKL is 8x minus 20. So MKL is this one right here. So I'm going to put 8x minus 20 so you can see it. And then JKL is the big guy, right? So the big guy is 10x minus 11. So first of all, you want to come across and say that the measure of angle JKM plus the measure of angle MKL is equal to the measure of the large one. So that's angle JKL. Now substitute, combine like terms, solve for x, and then don't forget to go ahead and finish up and give the measure of MKL and the measure of JKL. That's the only two that they asked for. Remember that 43 was already given for the other angle, and you're all set. Good luck.